So theorem 5.4 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Yes? Mike, thank you.
That's magic.
Now, theorem 5.4. All of these theorems that we're going to be looking at, my knees actually singing.
Oh.
So all of these theorems that we're going to be looking at are ways to prove that a parallelogram, that a quadrilateral is a parallelogram. So all of them are going to end with, then it is a parallelogram. Okay? So theorem 5.4, if both pairs of opposite sides are congruent, then a quadrilateral is a parallelogram. The only way we have right now to show that a quadrilateral is a parallelogram is to show that both pairs of opposite sides are parallel, because that's the definition of parallelogram. So when we draw a parallelogram up here, what we know about this is that both pairs of opposite sides are congruent. What we are going to need to show to prove that it is a parallelogram is that both pairs of opposite sides must be parallel. To do this, we're probably going to need to work with a transversal. And if I can show that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, since alternate angles are congruent, those lines will be parallel. Now, what we are given is that opposite sides are congruent. So AB is congruent to CD. And BC is congruent to AD. What we are going to prove is that these sides must be parallel. So AB to CD. And BC to AD. And I'm kind of actually ahead of myself. I should say what we're going to prove is that this is a parallelogram. This is the second to last step, because this would mean that we're working with a parallelogram if both pairs of opposite sides are parallel. So I'll just add that on the end since I'm ahead of myself. Okay. Do I have two triangles that must be congruent here?
Yes.
Why are they congruent? You're right, but why are they congruent?
Side.
Okay, this is a shared side. So triangle ABC. 2. And since 4 goes with angle 3, right? Then I would have to, since I said ABC, I would have to go CDA if I want the same corresponding order. Again, AB goes with CD. See how those are the sides with the 2 tick marks? So I have to name, if I go ABC, I have to go CDA. That would mean, since the triangles are congruent, that angle 3 is congruent to angle 4, and angle 1 is congruent to angle 2. state that the opposite sides must be parallel because alternate interior angles are congruent, which means this is a parallelogram. It's a parallelogram by definition of parallelogram. These theorems are mostly going to be converses of 5.1 through 5.3. We have one extra theorem. So there's one more way we're going to add in to prove that something's a parallelogram but is not a converse of what we've already learned. What that way is going to be is if one pair of opposite sides are both congruent and parallel, then it's a parallelogram. The theorem 5.5, if one pair of opposite sides of a quadrilateral congruent and parallel is the extra one that we're adding in, then a quadrilateral is a parallelogram. So this time when we draw our parallelogram, we can pick which pair of opposite sides we want to work with. We're going to have one pair that are both congruent and parallel. Again, we're going to want to work with a diagonal here. And this time we have a choice of ways to show that this is a parallelogram. If we can either show that both pairs of opposite sides are congruent because of what we have here, then we can show it's a parallelogram by theorem 5.4. Or, if we can show that both pairs of opposite sides are parallel, then we can show it's a parallelogram by definition of parallelogram. So our given information is that BC and AD are congruent and BC and AD are parallel. What we want to prove is that we have parallelogram ABCD. And we can get there by proving that AB is congruent to CD, which means both pairs of opposite sides are congruent. What I'm looking for is congruent triangles. And what I know is, since we have parallel lines, alternate interior angles are congruent. Does that mean we have congruent triangles here? Yes, because of the shared side, triangle ABC, and again, I have to be careful how I state the other triangle. is congruent to triangle. And since I went A, B, C, I would have to start with
CDA.
CDA. By side. This would mean that segment AB must be congruent to segment CD because they're corresponding parts of congruent triangles. And since both pairs of opposite sides are now congruent, this is a parallelogram by theorem 5.
What?
Yes.
I'm trying.
Yes. You can do it the other way. I will never force you to do paragraph proof, but
That's easier.
paragraph proofs are easier
A lot.
because you can kind of just assume since you marked it on your diagram, they're going to see it down here. Okay? You'll notice I leave out the given for one thing when I'm writing a paragraph proof. You'll also notice that some things I just let people assume because they can see the diagram. Now theorem 5-6. Theorem 5-6. If both pairs of opposite angles of quadrilateral are congruent, then the quadrilateral is a parallelogram. So what we are going to have is a quadrilateral with both pairs of opposite angles congruent. What I can do in this quadrilateral is call both of these angles x degrees and both of these other angles y degrees. And if I can show that x plus y has to equal 180, if I can show that this means that x and y are supplements, then I can state those lines have to be parallel because same side interior angles are supplementary. So the given information is that measure of angle B equals measure of angle D equals x. Also, measure of angle A equals measure of angle C equals y degrees. And what we are proving is that this is a parallelogram. We're going to go about it by proving the opposite sides are parallel. What do we know about the angles of a quadrilateral? What do they add to be?
360.
Yes. So adding these angles gives me 2x plus 2y equals 360. That's because of theorem 313, which says you can take the number of sides minus 2 times 180 to get the sum of the interior angles.
Fine.
If I divide everything by 2, this gives me x plus y equals 180. Since x and y add to 180, the same side interior angles are supplementary.
This is pretty normal.
And if the same side interior angles are supplementary, then lines are parallel. Yes. If opposite sides are parallel, then the quadrilateral is a parallelogram by definition parallelogram. That probably transfers pretty well. I know when I plot my marker down on the board, I don't think about it, but that transfers really well. It's a schmack. Sounds like I walk around and just
So if I went flat and do that at that what?
Oh, it's funny to do that. Ah!
thanks.
Well, there's always next period you can try with next class. No, there is no before the next class. You have to talk a lot.
Okay, theorem 5-7 now, which is our last theorem. Also our last way to prove something's a parallelogram. So theorem 5-7, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram.
That's not okay.
All right, almost done here, guys. So we have a quadrilateral, and what we know about this quadrilateral is that the diagonals bisect each other, which means they go through the midpoint of each other. What I am going to try to do using this information is prove that these triangles are congruent, which means that this pair of sides, AB and CD, are both congruent and parallel. I think I can get to, if I can prove these triangles congruent, that I have one pair of sides, opposite sides, that are both congruent and parallel. So, my given information.
Holy crap.
Okay, please, really, we only have a little time left. I'm going to try to get through this. Okay. What we are given here, Justin, is that AC and BB bisect each other.
Didn't play with that.
Alright. What we want to prove is that makes this a parallelogram. And we're going to do that by showing one pair of opposite sides of both congruent parallel.
You do this? You know what that flag is talking?
Alright. I'm going to get there by saying that these two triangles are congruent. Why are triangles A, we'll call that O, AOB and COD congruent? Yes, the vertical angles, right? It's actually setting this up.
Yeah.
Since those triangles are congruent by side angle side, then these sides right here are going to be congruent. Also, these angles right here are going to be congruent. So we can prove this by 5, which says one pair of opposite sides are congruent and parallel. So, segment CD is congruent to segment AD, and segment CD is parallel to segment AD. And they're parallel because alternate interior angles will be congruent. This would mean that we have a parallelogram by theorem 5. So, thank you for helping me out there. That's what happens when I'm distracted trying to hurry and also trying to keep your attention when I see that obviously that you are not paying attention.
I did it.
Okay.
About that trip.
Thank you anyway.